Good morning. It's my pleasure to share my interest in beluga whales with people from Pittsburgh. So I've worked with beluga whales since 1982. I always had an interest in marine mammals. For those of you who don't know, there's a country up there. It's called Canada. I give a broad perspective first. And the beluga whales that I will be talking about live in the eastern part, in the St Lawrence River. So that's where they are. And it's always a pleasure to explain why there are beluga whales there. My interest first started in 1978. I first sailed in the St Lawrence River, in the St Lawrence Estuary. And I discovered these wonderful animals that are white and are completely out of place in that setting over there. And later in my veterinary career, I realized that I could maybe do something with that, going to study, specializing in pathology and studying the animals that were always my interest since I was a kid even. So why to study wildlife? I give an environment course to my veterinary students, and I start with the question, why would we study wildlife exactly? Why would a veterinarian care about wildlife? A veterinarian in his career will treat maybe 3 species, 4 species of mammals, but what about the 5,445 other species? Who will care about these animals? And why would they study about that? I had a wonderful introduction with Val, so now you would know a little more why we would study about these animals. As sentinels, yes, as canary in the mine, yes, but the intrinsic value, that's what I try to discuss with the students. Why would we care beside that to our own use? And that is all a personal question for each of you. Your answers are as good as mine on that. But I try to get the students thinking. For instance, veterinarians will treat cats. Why cats when they are the only felid of 37 species that are not endangered? All the other 36 species of felids are endangered. So why would the veterinarians treat only one species? So it's open to discussion. So back in 1982, I see some smiles in the room. Probably these people are the same age as me because they know Sting and they know the song Biology, regardless of biology, the song Russians. It's very well applied to all wildlife. We all share the same biology. We are in the same environment. We are subject to the same infectious disease, to the same contaminants. So why would we study beluga whales in the St Lawrence River? Because they share the same environment as us. Most of the Quebec population is along the St Lawrence Estuary. A lot of drinking water comes from the St Lawrence Estuary. So if these animals are sick, if they cannot live in that environment, what about us? Maybe we are the next one on the line. So that's I see the immediate reason why to study beluga whales. They are not endangered as a species, but the population in the St. Lawrence River is. So it's always that distinction between a population and a species. There may be 50,000 beluga whales in the Arctic, but only around 700 to 800 in the St. Lawrence Estuary. So these are the southernmost beluga whales in the world, the St. Lawrence. It's a permanent population. They live there since 10,000 years. That's a distinction with other marine mammals like blue whales that only visit on a seasonal base. The St. Lawrence is the waterway that drains the most industrialized quarter of North America. So here you have a good example. The past of Pittsburgh is industrial. As is the shoreline of the Great Lakes where the car industry took place. So we gathered all the contaminants from the eastern part of North America. These animals are long-lived, they are fat, so they accumulated all these contaminants since the last 100 years, basically. And they have been isolated there from Arctic population since 10,000 years, and they are only 500 kilometers, which is 300 miles away from the College of Veterinary Medicine. So the first years when I started in the 80s, I literally tracked the carcasses to the College of Veterinary Medicine to do the necropsy. I had waving from tourists on the highway, waving at me with the long white tail wagging behind the pickup truck. These were the happy years. So here the numbers. The raw numbers before 2007, they had counted, biologists had counted no more than 460 beluga whales. And that increased in 2007, but it's very imprecise. I think the population is declining slowly, and that's also the consensus of the biologists working in the field. So why beluga whales? They have a long lifespan, about like a human lifespan. And like many North Americans, they have a large percentage of fat. If I look at the room here, it's not too bad, but in some rooms I've seen more similarity. So they are top predators like human. You would think that is decreasing when you go to the grocery store. The meat part in our diet is decreasing, but we are still top predators. And all that together does that they accumulate contaminants. They accumulate the legacy contaminants like P.C.B., which are lipophilic, so they are fat-loving contaminants, and they accumulate for a long time. They eat a little bit of everything. And they also have, like humans, they have babies, they have a long lactation, and their milk is 40% fat, so they transfer a lot of their contaminants to the babies, exactly like in women. We have a research group in Quebec of doctors working on Inuit women in the Quebec northern part, and they find that Inuit women are contaminated a lot because they eat beluga whales. Even in the Arctic, beluga whales are contaminated. They are more contaminated in the St. Lawrence River. Anyway, so that's another parallel with the human health. So the female basically has less contaminants than males because it transfers its load to the newborn. It's a good news for the mother. It's a bad news for the newborn because the newborn has often extremely high loads of PCB and even DDT, because these animals have accumulated that for a long time. So the animals, when I started my master's degree, it was thought that beluga whales dive no more than 20 meters. And now we know that they dive more than 1 kilometer deep. And they go to the bottom and they eat worms living in the sediments, where they are contaminated by another family of contaminants, PAHs, polycyclic, aromatic hydrocarbons. Basically, PAHs are what is in cigarette smoke and give lung cancer. So it's produced also by metallurgy. So these animals are contaminated also by eating worms in the bottom by another family of contaminants. PAHs are carcinogenic. The endocrine effect, yes, they have some endocrine effect, but I think that in regard with the carcinogenic effect, that's not a big thing to consider. There's a whole part of our work that concerns PCB, DDT, and the hormonal effect. I won't talk about it here. I give the references for those of you who are interested. So the St. Lawrence River in winter, we still have winters over there. They are softer and warmer, but that gives you an idea why there are beluga there. It's a little bit like a subarctic climate. So that's part one. And also because the current of the Labrador enters the St. Lawrence River. Cold water is dense. Cold water sticks to the bottom. It enters the St. Lawrence River. And there is a current toward Montreal, towards the Great Lake in the depth of the St. Lawrence River. Here is the area where the beluga whales live. There's the Saguenay River, that's the St. Lawrence Estuary. These are brackish water. It's salty. It's almost like the ocean. But here you have the Saguenay River. It's soft, fresh water, and it floats on the surface. And beluga whales love it because it's a mixture of water that makes a lot of fish, lots of oxygen, lots of food, plankton coming from the Atlantic by the Labrador current. There's a submarine cliff there in Tadoussac. That's where the movie Hotel New Hampshire was filmed, because it's a fantastic place. There's a fjord, there's a wonderful hotel. That's why they use it as a cinema setting. Anyway, so if you take a camera underwater and you take a picture looking towards Montreal, you see here the St Lawrence channel, 300 meters deep. So that's really deep. And here in Tadoussac, it's 30 meters deep. So the upwelling, the current, the Labrador current coming from the Atlantic, loaded with plankton, comes there, hit the wall, goes to the surface. There's a huge upwelling. That's why the water is colder there. That's why beluga live there, mostly eating little fish that eat on plankton. And you have fog in the summer, and it's hard to see beluga whales in July. Don't go there in July. Okay, so that's why beluga whales are there. Basically, the St Lawrence Estuary shares with the Baltic Sea a lot of features. The biological diversity is not so high, but the mass of fish is. Okay, cold water is richer in oxygen, that's why there are more fish, but the number of species is lower, let's say, than in the tropics. Okay. But the diversity is not so high, and that's as the biodiversity is lower, the system is not so resistant to aggressions by pollutants and by other changes. Okay, so we have visitors. That's a blue whale coming in October. They have their babies in the south, but they come to feed in the St. Lawrence River because the food is abundant. We have red tides because of all kinds of reasons, climatic changes. We had in 1998 a mortality of many species, beluga whales, birds, and it was due to dinoflagellate. There is a municipal waste. There are fertilizers dumped in the St. Lawrence River. So this does create hypoxia. That's why probably cod disappeared from the St. Lawrence River. If you take here the hypoxic zone in the St. Lawrence, the yellow dots gives you the red dots gives you the area where cods would die almost instantly because the lack of oxygen in the bottom, in the deeper layers of water. The yellow dots, it's where they would last only 4 days, 50% of them. So the food for beluga whales has probably decreased following these changes. And now it's a part that I documented a little more recently. Why exactly are beluga still living there after 10,000 years? And you will see where the point is. There's a relation in there with Pittsburgh. So 10,000 years ago, North America was covered with a 1 mile thick ice crust. 10,000 years is 5 times Jesus Christ. It's not so long ago. It's recent in geological history. We find still beluga whales on top of little mountains near Montreal from 10,000 years ago. We find bones, of course, not beluga whales. Okay. So here it gives you an idea. In yellow, we have the ice crust 12,000 years ago. 9,000 years ago, the ice crust has receded. You have the Sea of Champlain. So the weight of the ice was so huge that the crust was caving in. So the Atlantic came in, made the Sea of Champlain. Later, there was a global warming. The ice receded. So that's 13,000 years ago. You see the cities of Quebec province here underwater. The same was true for Ithaca, where I studied. In upper New York State. Beluga whales were there, narwhals were there. There were even Inuits hunting them 10,000 years ago. So that's not really so past. So what happened is that the receding glacier, the weight of that ice is not there anymore. So the earth crust bounces back with the river and the lakes left by the eroding ice cap. And what you have there is that it's bouncing up, and you have a lot of waterways, you have a lot of lakes that are now above the sea level. So that is always a question I ask my students, and there's always one or two that have the right answer. What does it create for in terms of energy when you have water above sea levels? Is there anybody that can think about it? It's a little challenge this morning. Make it lively. No?
Do you think of hydroelectricity?
Hydroelectricity, okay. So in Quebec, we have cheap hydroelectricity that our government will sell to anybody around for almost nothing if you want to invest. So cheap hydroelectricity, when you have that, you have metallurgy and smelters, okay? Because you need lots of electricity to make electrolysis on metals, on rough metal to get aluminum, for instance, okay? So if you want to put a tariff of 25% on aluminum, you have to also to think about where you will take the energy for it, okay? So that's just in the news recently, maybe. So I even saw in the financial pages that aluminum financial businessmen called it frozen electricity because it takes a lot of electricity to get aluminum from bauxite, which is a rock, a rough rock. So if we say metallurgy, now you see the link with what I'm talking about. You see also the older process, the older industrial process, like Soderberg process. It was in fact having lots of electricity going through coal, to an anode made of coal. And that coal, by burning, released lots of PHs in the environment. And that's how that Beluga Whales got contaminated with the coal. So it's a little summary that was in the financial pages, that expression of frozen electricity, really good. Okay, so here you have the area. Now in red you have where there is more cancer, and we'll talk about it a little later. And you have the 5 smelters of a company that was called Alcan, which is now which was bought by Rio Tinto. And that's where 60% of the aluminum production in Canada is produced. The whole area would not exist without these aluminum smelters. There would be no cities, no villages, nothing. There will be only maybe some lumberjack cutting wood. So there are lots of similarities when you think about it with a city like Pittsburgh or even Detroit. So my work was to examine those animals. We had all kinds of conservation, preservation status. Some were in good shape, some were somewhere in bad shapes. Most of the animals we examined were code 2 or code 3, so in reasonable condition to allow to determine the cause of death. This is in 1982. That was the second Beluga whale. I was starting my master's degree at the College of Veterinary Medicine, so I trucked them along to the college. Here's a beluga, and here's me. I'm on the left with the woolen cap. The beluga whale is there, the white one, but without the wool cap. Okay, so that's our necropsy room where we examine these whales. We have a newer necropsy room now, but we go through a usual post-mortem, slicing the lungs to see if there are masses or if there is some pneumonia, infection, parasites. This is another kind of a disease, just for fun. That's the calf that is cut in the pelvic canal. It's a dystocia. So usually either the tail or the head comes first, but sometimes they get bent, and that's the back that was stuck in the pelvic canal. That's the placenta when we extracted the calf from there. Both the mother and the calf die, of course. So over the years, we had 400, more than 400 the beluga whales, 222 that were examined. We aged them. Oops, I lost my. Sorry. I want to put more in my pocket. There we go. Thank you. So we cut the teeth with the help of Fisheries and Oceans Canada. And sorry, I'm forgetting all that area there. And so we cut the teeth and we count the layers like a tree, and we age them. And that's pretty unique. At least 20, 30 years ago, many studies on marine mammals, they didn't count, they didn't age the animals. So we could age them, and that was very good. to have more data. So you see the mortality pretty constant until lately. We had many newborns who die. We don't know exactly why. I suspect that it's a disturbance by noise because the traffic has increased there, and that should not be allowed in an area like that to have outboard engines running and Zodiac all day long. I think it disturbs the mother, the pregnant mother. So it gives you an idea of the cause of mortality. In purple, you have the oldest beluga whales. So it was rather various. Here's the undetermined causes. And for cancers, we have older beluga. Now, that's pretty unusual to have 20%, 18%, depending on the years of animals, of a wide population of mammals dying. It's more like 1 to 2% in similar studies that have been carried out. In marine mammals, in cetaceans, you don't have more than 1.5% of mortality due to cancer. Here we had a lot of mortality due to cancer, and especially the digestive system. We had cancer of the intestine, but not any part of the intestine, the part that is close to the stomach, the equivalent of a small intestine. So in humans and in animals, you commonly have cancers, but in the distal parts, in the large intestine. Here it was in the small part. So that's what the cancer looks like in beluga whale. It looks the same, exactly the same as in a human or in a dog or in a kangaroo. My daughter is an oncologist now, and she sees exactly the same in human. So microscopically, you have structures looking like crypts, like intestinal glands, but they are deep in the wall. They distort the structure of the organ. That's called cancer. Here is the first gastric compartment. Here's the second gastric compartment. That was an ulcer. We look at the microscope. We find tumor cells from the gastric lining. So that cannot help but talking about the similarity with cows. That looks like a rumen, believe me. So those of you who have looked at the cow, the inside is exactly like that. Here it looks like an abomasum, the second gastric compartment in a cow. That betrays the evolution. They come from ruminants. Okay? 50 million years ago, all whales were antelope in Pakistan running in the desert. And suddenly one of them got in the ocean, ate a fish, and there were fins growing. So when you believe Darwin, you believe that. Now, you are creationists here. We won't get in that. Okay. So what this shows exactly is that the percentage of cancer increase with age, like in humans, okay? So that also showed that it increased with age. We had mammary gland cancer as well. It increased with age. With the decades of examination, the percentage of beluga whales with cancer decreased, as did the pollution, the pHs in the bottom decreased. And here, which is really interesting, is that with the decades of birth, the beluga whales that were born when the pH contamination was worst have the GI tract cancer. But the beluga whales born after that, we don't find cancer anymore, in other words, as simple as that. So beluga whales that were exposed to the most contamination, only them have cancer, and since the pollution has reduced, the cancer frequency has disappeared, actually. So here is the pH concentration in the bottom, and you have the history of the aluminum exploitation in that area. So the aluminum smelter started in 1926. So in the sediments, you have no pHs. And when it starts to expand, you have that huge peak of pH in the sediments. What happened is that there are big scrubbers in the chimney, and all the garbage from the scrubbers was released directly in the river in a liquid form. So you have that, which explains that peak there. And also that beluga whales born before that, I think at least it's consistent with pHs playing a role, were contaminated and had cancer because of that. 1990, that highly polluting process, Soderberg process, is phased out. There's still one smelter that uses it until 2002. You will see why this becomes important. So here it's about aluminum production in the Saguenay River. So it's a really important part of the aluminum production in Canada. Here, this shows the contamination level in the bottom, in the sediments. So here in the orange, you would have the concentration of PAH would correspond to what you find in an industrial port in Japan, okay, in an industrial harbor in Japan. So this really doesn't look like it, because exactly in the middle where we had an orange concentration of pH, you have these dreamy landscape of a fjord. It's the only fjord, by the way, on mainland North America. There are fjords in Newfoundland, but not on the mainland beside the Saguenay River. So there's a history of aluminum smelter there. A lot of pH were released. It has been signaled before by researchers at Fisheries and Oceans that probably bad for the health of people there. In Beluga Whales, we found the adducts back in 1988 in the tissues from Beluga whale, and we had Arctic Beluga whales without these adducts. Where it comes really interesting, in 1983, there were cancer in aluminum workers, urinary bladder cancer and lung cancer. That was the year where we found the first cancer in Beluga whales. So there's also cancer in people living there, and not only in the aluminum workers. It's a GI tract cancer also increase in the people living there. The same in the women and men. In men, it's not so noticeable. So what happens is, the question is why the cancers in the general population and the cancers in the aluminum workers would not be the same cancers. There's a common point there, the drinking water. In the smelters, they drank bottled water, and the women at home in those days drank mostly water from the wells, from the surface waters in the area. So I think that can explain a lot. So just an update, we are looking for pHs in the tissue of Beluga whales in the intestine with the antibodies with Dr. Miriam Poirier at NIH. And here we find no pHs in the tissue of captive Beluga whales kept at some North American aquarium. We look in the Arctic, here we find that's the intestinal tissue. In the nucleus, there's no pHs. When we look at Cook Inlet, Alaska Beluga whales, we start to see red nuclei, which are signs of pH DNA adducts. When we look at St Lawrence, we see flashing nucleus, which means pH DNA adducts in the nuclei. So to summarize, we have lots of pH DNA adducts in the SLE, St Lawrence Estuary, and less in Cook Inlet, and so on. So I won't have time to talk about Cook Inlet. Just to conclusion, when we published these results, I received a letter from Alcan saying that they don't pollute. That's not them. They have nothing to do with that in 2002. And that's everything has been fixed. No problem. They have nothing to do with cancer in Beluga whales. So that's the signature of the environmental affairs of director of Alcan. They sent a copy to the president of the Université de Montreal at the time, to my director, and all that. I felt like Erin Brockovich. Yeah, Brockovich. But they were supposed to keep the plant open for another 15 years, and they closed it in 2004 because then they admitted that they pollute and that it was a good thing to close for economical reason, but also because it was highly polluting. Yeah. Thank you. Thank you.
I think we have time for one question. Sure.
The carcasses, does that give you a bias in your sample, or are there other things?
Or are there other ways to identify a sample to take from?
I'm sorry, I didn't understand.
So you're finding carcasses and using that to identify what the population health is? Does that give you a bias, or are there other ways of understanding what the
When
population?
we look at that population, if it gives us a bias, I'm not sure I understand still. I'm sorry.
You only find dead ones.
Yeah.
You only get the dead ones, right? to test. So you don't know what the ones.
That's so interesting, because for 30 years I had a debate with the biologists at Fisheries and Oceans Canada. You look at the dead ones, so they don't represent the living ones. But I said, whoa. If you go to a hospital, and if you go to the morgue and you look at the death certificates, of course it gives you an indication of the status of the living one. You go in a village in Africa in 1970, and if you would have done autopsies and you would have found signs of HIV, it would have told you there is HIV in the population. It's a bad example, but when you look at the cause of death in the dead animals, of course it gives you an idea of the status of the living ones. For me, I cannot, you know what I mean? You go to an hospital, if you have an epidemic of influenza, it tells you there's influenza in the population, even if you find influenza in the dead people, yes? Okay. Thank you.